Okay, so in this video we will see the load application in STAAD Pro. Okay, in the last video we calculated the various types of loads, that is dead load and live loads. So in this session we will see how to assign the same loads in STAAD Pro. So first and foremost thing, you need to create load cases. You need to create load cases in STAAD Pro. So first you go to STAAD Pro software. In case of loading, load case details, you go to load cases details. You click on add button. So number 1, dead load. So here you write dead load and click add. Okay, next second number, so that is live load. Live load, click add, close. So we have created two cases, two load cases. One is a dead load and another one is live load. So first you need to create two load cases, that is one is dead load and another one is live load, or it is imposed load. Okay, so we created dead load and live load, two load cases. So here we will be using a different method. Instead of load cases, I will create in this reference load definitions. You click on this reference load definitions, you go to add. So here it is, first it is dead, so type name as reference dead load, you click add. Next is reference live load, you click add. I will create another combination for roof live load, so that is reference roof live load, add, close. So in reference load definition we have created three cases. One is reference DL, it is R1, reference 1. Reference 2 is reference live load. So R3 is reference roof live load. Here it is floor, it is roof. Okay, we created three cases. First we shall assign self weight. First we shall see how to assign self weight. So it comes under dead load. In dead load we will be seeing how to assign self weight. Okay, so you go to STAAD. In case of reference DL, you go to add, self weight, direction should be Y, factor should be -1. Y direction is Y, STAAD uses global axis where y is vertical. Since gravity acts vertically, self-weight is applied in y direction. So you should select y. Y factor -1. Okay. If you use -1, applies full self-weight. It will apply full self-weight. Okay. What if factor is -0.8? It applies 80% of actual self-weight downward. Okay. So we need 100%, which means full self-weight acting downward. So we will be using -1. So some designers use -1.05. So this extra includes for fasteners. Okay. While in case of connections, we use various types of welds and bolts. So this 5% it is included for fasteners. Okay. Anyway, we will be using -1. So you click on add, close. Okay. So if you observe here on self-weight, you have a question mark, which means it is the load self-weight is added only but not assigned. So how to assign this self-weight to entire structure? So you first select the entire STAAD model. Okay. You click on this self-weight. You click this option, assign to selected beams and plates. You click assign, assign. See here. Now the question mark is removed. Okay. So first is self-weight. Next is, in case of dead load, wall loads. So we will assume all your frames, periphery frames are loaded with walls. So this will be only on periphery. Let us assume all the outer steel beams were having some masonry loads. So wall thickness, is 0.2 meters and your wall is made up of AAC blocks. AAC blocks. Okay. So density will be 8 kilonewton per meter cube. Okay. Height of wall, which means in our case, floor to floor height. In our case, floor to floor height is 3 meters. In our model, we considered floor to floor height as 3 meters. So wall height is 3 meters. This is nothing but your floor to floor height without deducting the beam depth. So density 8 kilonewton per meter cube multiplied by thickness of wall 0.2 meter multiplied by height of the wall 3 meters. So it comes around 8 multiplied by 0.2, 8 multiplied by 0.2 multiplied by 3, which is 4.8. 4.8 kilonewton per meter. So use only for periphery beams. Okay. So open your STAAD model. So first you go to reference dead load. You click on add. You select this member load. So direction is GY global Y minus 4.8. Minus 4.8. So calculated value is 4.8. So minus 4.8 uniform force. Okay, add, close. Okay. Next is you have to select only the you select only floor beams. You do not select these roof beams. You go to this new view, create a new view, new window for the view. You click on OK. See here. Again in this, you need to select these periphery beams only. Okay, these outer beams only. You are not supposed to select any these inside beams because there is no wall loads. We assume wall loads only on the peripheral beams. So for which you use control button. If you want, you can rotate your model. You can change the view. To first select like this. You go to isometric view. See here. In this case, all your internal beams are got selected. You should be very careful while selecting the beams. You press Control key on your keyboard. Am I selected the correct beams? Yes. I have selected only the outer beams. Okay. Peripheral beams. You select this load minus 4.8. Assign to selected beams. You click this option and you click this assign. Yes. See here. All your peripheral beams are loaded with load of minus 4.8. Okay. So you next click this display whole structure. See here, all your peripheral beams are loaded with, this is your self weight and these are your loads. Next is on parapet wall load. So once you completed wall load, next third will be your parapet wall loads. Parapet wall loads. Same, we will be assigning this parapet wall loads only on peripheral beams. So height of parapet wall height 1.2 meter. Again, these walls are made up of AAC blocks of density 8 kilonewton per meter cube. We assume wall thickness as 100 mm. We assume parapet wall thickness as 100 mm. So it is 8 kilonewton per meter cube multiplied by thickness 0.1 meter 100 mm, height of the wall 1 meter. So 8 multiplied by 0.1 multiplied by 1. So which is 0.8 kilonewton per meter. 0.8 kilonewton per meter. Okay, this parapet wall load which will be assigned only on roof floor. You go to STAAD model, you select front elevation, front view, you select only the roof beams, you go to 3D view. On roof beams, you unselect this internal beams. Okay, you have to select only the external beams. You go to reference dead load, you go to add member load minus 0.8 in gravity y direction. You click on add, close. Okay, you select this minus 0.8 kilonewton per meter. You click this option assign to selected beams. Click on assign. Yes, see here. These beams are loaded with 4.8 kilonewton per meter. Okay, whereas these beams are loaded with 0.8 kilonewton per meter. So these are your parapet wall load and these are your partition walls. Okay, so this is how you can assign the line loads. So next, once it is completed, so next is so these are your line loads. And these are also line loads. Okay, this is self weight. Next fourth type is floor loads. In floor loads, we have self weight as well as floor finishes. So these two are together are dead loads. Dead loads. In addition to which we have live loads. Okay. So self weight. For self weight, we assume checkered plates. We assume all the floor systems are made up of checkered plates. Okay. We calculated the weight. In the last session, we calculated the weight of checkered plates. It is weight of 6 mm plate is 0.5 and finish it is 50 mm finish. Okay, first we will assign the weight of checkered plate. So first we will assign the weight of checkered plate. It is 0.5 kilonewton per meter square. Weight of checkered plate. So you go to STAAD model, you go to reference DL, you go to add. Now you go to area load, in which floor load. So it is, what is the calculated value? Minus 0.5. Minus 0.5. So Y range. So you need floor elements in this here to here. So here Y is 0 and here Y is 9. So here it is 3, here it is 6. You simply give Y range 0 to 9, 0 to 9. You click on add, close. It is only added. You just click this here. It is added. So this is the weight of checkered plate. Weight of checkered plate. Okay. Next is finish. On top of checkered plate, we have finish. For roof, we have finishes. On roof, we have 100 mm finish. On floor, we have 50 mm finish, because on roof we need waterproofing. So we will be using 100 mm thick finish. On floor it is 50 mm thick finish. Okay. So density of cement mortar 20 kilonewton per meter cube multiplied by 0.1 meters. Here it is density 20 kilonewton per meter cube multiplied by 0.05 meters. So we shall calculate the loads. So 20 multiplied by 0.1, it is 2. So 2 kilonewton per meter square. Next 20 multiplied by 0.05. It is 1 kilonewton per meter square, which means on floor, on all the floors, your floor finish value is 1 kilonewton per meter square. On roof, which means topmost area, so floor finish is 2 kilonewton per meter square. So you go to STAAD model. See here, these are your floor. So we will be using floor finish of 1 kilonewton per meter square, and this is roof. We will be using floor finish of 2 kilonewton per meter square. We know the y coordinates. Here it is -2, 0, 3, 6, 9. Okay, you remember these values. Here we need to separately add the load. So floor finish between 0 to 6. So for this it is 9. So you go to this reference DL. You click add floor load. First is -1. So Z value, it is start, minimum is 0, maximum is 3, 6. You click add, close. You select this. See here, the load is added only for this floor 0, 3, 6. Next you click this reference DL, go to add floor load -2, minimum is 9, maximum is 9. You click add, close. See here, this -2 is added only for this roof floor. See, whichever the load I select here, which will be highlighted in blue color. So this is -2, roof finished load. This is -1. These 3 floors are highlighted in blue color. Okay. This is point -0.5. This is weight of checkered plate. It is added for all the floors. This is 0.8 parapet wall load. This is -4.8 partition wall load. Okay, next is live load. Next is live load. I told in the last video. So this is used as storage, and this is commercial space, and this is commercial space. This is accessible roof. Okay. For storage, we will be using live load 5 kilonewton per meter square. So for this 2.5 kilonewton per meter square. For this it is 2.5 kilonewton per meter square. Accessible roof live load is 1.5 kilonewton per meter square. Okay. So for this I will be using load case. For this I will be using load case reference LL, reference live load, reference live load. For this I will be using load case reference. I will be using reference roof live load. Again you remember the Z Y coordinate. Here Y is -2, 0, 3, 6, 9. To assign this 1.5, your y ranges between minimum 9 to maximum 9. To assign this load, y ranges from 3 to 6. Minimum 3, maximum 6. To assign this load, y ranges from minimum 0 to maximum 0. Okay, I will be working in this front view. So you go to live load, you click add floor load, it is -5. So range is 0 0 0 0. You click add, close. See here, it is used as storage. So live load is in this region only. Next you go to reference live load, you click on add floor load, it is -2.5. Okay, so here it is minimum range is 3, maximum range is 6. Add, okay. See here, now it is in blue color. These two floors are with -2.5. Now I go to reference roof live load, you go to add floor load -1.5. So here it is 9 9. Close. See here, this is loaded with roof live load. You go to isometric view, see here, this is on roof. These two are 2.5, -2.5 commercial space, and this is 5. Okay, so this is how you can add the loads. Once everything is completed, you go to save. On keyboard you press Ctrl S. Okay, once the load assign is completed, the last step is you bring these reference load definitions to here. Okay, how to bring? On load case details, you click add, sorry, you click on dead load. In case of load case details, you click this dead load, add, you select this repeat load in this reference load. So dead load means you select this reference DL with factor 1, you click add, close. In case of live load, you go to add, repeat load, reference load. Live load means you have two types. One is floor live load, another one is roof live load. You bring these two combinations here with factor 1, you click on add, close. Okay, so this is how you can assign the or complete the load application in STAAD Pro. Okay, so you practice this much. Next, in the next class, we will see how to generate the load combinations. Okay, this is self weight -4.8 partition wall load, -0.8 parapet wall load, and this -0.5 is weight of checkered plate, -1 is floor finish for floors, -2 is floor finish for roofs. Next, this is storage, -5 live load, -2.5 commercial space. You have two floors, 3 and 6. Next, On the roof, you have a live load minus 1.5, which is accessible roof. Okay. To practice this much. In the next video, we will see load combinations. How to generate the load combinations and how to perform the basic analysis.